Imagine a world where a particle can exist in two places at the same time. Welcome to quantum mechanics. This is the science of the very small, the universe's tiniest building blocks. It's a branch of physics that dives deep into the realm of the infinitesimal. Atoms, electrons, photons, and the likes. But hold on, it's not just about the small stuff. It's a fundamental theory that describes how the universe works at the smallest scales. Quantum mechanics is like the secret agent of physics, operating behind the scenes, pulling the strings of the physical world. It's the rulebook for how particles behave, interact, and exist. It's the codex that explains why the sun shines, why the ground beneath your feet is solid, and why your computer works. But here's the twist. The quantum world is nothing like the world we see around us. It's a world where particles can be in two places at once, a phenomenon we call superposition. It's a world where particles can be linked across vast distances, a concept we know as entanglement. It's a world where particles can behave like waves, and waves can behave like particles, an idea we refer to as wave-particle duality. Quantum mechanics is strange, mind-boggling, and counterintuitive. It's a world where the usual rules of physics don't apply, where reality is blurred, and uncertainty is the only certainty. But don't let that intimidate you. The quantum world may be bizarre, but it's also fascinating, full of mysteries waiting to be uncovered. So, quantum mechanics, in essence, is the study of the invisible, the microcosmic world. It's about exploring the realm of the tiny, the realm where our everyday intuition fails us. It's about delving into a world of particles that are here, there, and everywhere, a world that's as fascinating as it is perplexing. So, stick around, because we're just getting started on this quantum journey. Now, you might be wondering, how is quantum mechanics different from the physics we learned in school? Well, let's dive into that, shall we? In our day-to-day life, we're used to objects behaving in a predictable manner. If you throw a ball, you can calculate its trajectory. This is the realm of classical mechanics, the physics of the macroscopic world. It's a system of laws that perfectly describes the motion of planets, cars, and even cricket balls. But when we zoom in, way in, to the atomic and subatomic level, these laws start to break down. Here we enter the realm of quantum mechanics. It's a bit like stepping into a wonderland where the usual rules don't apply. Particles at this scale don't behave like tiny billiard balls, as one might expect. Instead, they exhibit wave-particle duality. This means they can behave both as particles and waves. Imagine if you could be both at home and at the grocery store at the same time. Sounds impossible, right? But that's the norm in the quantum world. Then there's the concept of superposition. In classical mechanics, an object has a definite state. But in quantum mechanics, a particle can be in multiple states at once. It's as if Schrödinger's cat is both alive and dead until you open the box to check. And let's not forget about entanglement. This is a phenomenon where particles become interconnected. Change the state of one particle, and the other changes instantaneously, no matter how far apart they are. It's like having a pair of magical dice that always land on matching numbers, even when rolled on opposite sides of the planet. In other words, the physics we're accustomed to can't explain the behavior of the tiniest particles in the universe. So, we need quantum mechanics, a theory that, while strange and counterintuitive, allows us to understand and predict this bizarre quantum realm. Let's dive deeper into the weird and wonderful world of quantum mechanics. Buckle up as we embark on a journey through a reality that's a far cry from what our senses perceive. First, let's tackle wave-particle duality. Picture yourself on a beach, watching the waves crash against the shore. Now imagine if each of those waves was also a particle, like a grain of sand. This is the essence of wave-particle duality. Light and other quantum particles behave both as particles, with a definite position, and as waves spreading out through space. Next, we encounter superposition. Think of a coin flip. Before it lands, we don't know whether it's heads or tails. In the quantum world, it's as if the coin is both heads and tails at the same time until we look at it. That's superposition. Particles existing in multiple states simultaneously until observed. Finally, let's meet entanglement. It's like the ultimate long-distance relationship. Two entangled particles, no matter how far apart they are, will always be connected. Change the state of one, and instantly, the other changes too. It's a phenomenon that even baffled Einstein, who called it spooky action at a distance. These concepts, mind-bending as they are, form the foundation of quantum mechanics. They challenge our everyday understanding of reality and force us to see the universe in a completely new light. But don't let the complexity intimidate you. Quantum mechanics may be strange, but it's also incredibly fascinating. It opens up a world of possibilities that were once thought to be in the realm of science fiction. It's like stepping into a parallel universe where the laws of physics as we know them are turned upside down. You might be thinking, why should I care about quantum mechanics? Well, here's a little secret. You're already using it. Quantum mechanics might seem like a realm of abstract theories and experiments, but it has profound implications for our daily lives. Consider, for instance, your smartphone. It's not just a handy gadget. It's a testament to the power of quantum mechanics. The transistors that are the backbone of your phone's microprocessor wouldn't be possible without understanding the quantum behavior of electrons. Every time you send a text or take a selfie, you're harnessing the power of quantum physics. But it doesn't stop there. Have you ever marveled at the precision of a laser pointer or the detailed images produced by an MRI scanner? These devices, too, owe their existence to quantum mechanics. Lasers work by stimulating atoms to emit light at specific frequencies, while MRI scanners use the quantum properties of atomic nuclei to generate detailed images of the body's interior. Quantum mechanics has also paved the way for new technologies that are still in their infancy. Quantum computers, for example, promise to revolutionize computing by solving problems that are currently beyond the reach of even the most powerful classical computers. Meanwhile, quantum cryptography is set to make our online communications more secure by harnessing the unique properties of quantum particles. So while the principles of quantum mechanics might seem strange and distant from our everyday experience, they're actually closer than you think. Every time you make a phone call, watch a movie on your laptop, or undergo a medical scan, you're benefiting from the fruits of quantum research. And this is just the beginning. As our understanding of the quantum world deepens, who knows what new technologies and discoveries lie just around the corner? Quantum mechanics is not just an intriguing scientific theory. It's a key that unlocks the door to the future. Indeed, without quantum mechanics, much of the technology we take for granted today would not exist. So we've just scratched the surface of the fascinating world of quantum mechanics. We've embarked on a journey into the realm of the incredibly small, where the rules of the game are vastly different from those of our everyday macroscopic world. We've talked about how quantum mechanics is the study of the behavior of matter at the atomic and subatomic level. It's a field that's as perplexing as it is captivating, with laws that seem to defy our common sense and challenge our understanding of reality. We've contrasted quantum mechanics with classical mechanics, the physics that governs the behavior of everyday objects. While classical mechanics works well for describing the motion of planets or the trajectory of a thrown ball, it falls short when we dive into the realm of atoms and particles. We've introduced you to some of the key concepts of quantum mechanics, such as wave-particle duality, superposition, and entanglement. These concepts, though strange and counterintuitive, are fundamental to our understanding of the quantum world. Wave-particle duality tells us that particles can behave both as particles and as waves. Superposition allows particles to be in multiple states at once, and entanglement lets particles instantaneously affect each other, no matter how far apart they are. We've also touched on how quantum mechanics impacts our daily lives. From the technology in our smartphones to the future of computing, the principles of quantum mechanics are shaping the world around us in ways we might not even realize. Remember, this is just the tip of the quantum iceberg. Stay tuned and subscribe for more mind-bending explorations into the quantum realm. And don't hesitate to drop your questions or thoughts in the comments. Until next time, keep questioning.